Hi dear children, the next section of the chapter surface area and volumes, that is conversion of solid from one shape to another. Okay, in this section we are using the concept that the volume of the solid after conversion. Okay, volume of the solid after conversion is equal to the volume of the solid before conversion. Volume of the solid before conversion. Okay, this concept we are using to do the problems in this section, that is the volume of the solid after conversion and the volume of the solid before conversion, they are equal. So the first question, exercise 13.3, first question. A metallic sphere of radius 4.2 centimeter, radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. Okay, the first shape, that is a sphere, and now we have one cylinder. Okay, that sphere melted and recast into the shape of a cylinder. Okay, so the volume of the sphere, that is equal to the volume of the cylinder. Volume of the solid before conversion is equal to the volume of the solid after conversion. Okay, so since the radius of the sphere, that is 4.2 centimeter, volume of the sphere is equal to, what is our formula? 4 by 3 pi r cube. Volume of the sphere, that is equal to 4 by 3 pi r cube, that is equal to 4 by 3 pi into 4.2 all cube centimeter cube. 4.2 all cube centimeter cube. This is the volume of our sphere. And since the radius of the cylinder is given and height is not given, that we need to find. Okay, height we need to find. Let height of the cylinder, let it be capital H. Height of the cylinder, let it be capital H. We know that the volume of the cylinder, the formula, what is the volume of the cylinder? Pi r square. Since I took the height of the cylinder as capital H, pi r square H we will have. Okay, and this is equal to pi into radius, we know 6 square into H. Pi into 6 square into H. Now, since the volume of the solid after conversion and the volume of the solid before conversion, they are equal, we can equate, since it is equation, put it as equation number 1 and equation number 2, we can equate equation number 1 and equation number 2. Okay, according to the question, equation number 1 equal to equation number 2. According to the question, equation number 1 is equal to equation number 2. That is, just equate equation number 1 and equation number 2. 4 by 3 pi 4.2 all cube is equal to pi 6 square h. Pi 6 square h. On both sides we have pi, so we can cancel that pi. Then we will get 4 by 3 4.2 all cube is equal to 6 square h. Okay, 4 by 3 4.2 all cube is equal to 6 square h. Now take this 3 into the side, that is 4 into 4.2 all cube is equal to 3 into 36. Okay, 3 into 36 into h. We need to find out the value of h. So h is equal to what we will get? 4 into 4.2 all cube divided by 3 into 36. 4 into 4.2 all cube divided by 3 into 36 we will get. After simplification, we will get the value of h, that is 2744 divided by 1000. 2744 divided by 1000, that is equal to 2.744. 2.744, that is the height of the cylinder is equal to 2.744. Now second question, metallic spheres of radii. Here we have 3 metallic spheres. Okay, the radius, first one is 6 centimeter, second one is 8 centimeter, and third one is 10 centimeter. Metallic spheres of radii 6 centimeter, 8 centimeter, and 10 centimeter respectively are melted to form a single solid sphere. Okay, so the first volume of the first sphere, or the volume of the sphere with the radius 6 centimeter, volume of the sphere with the radius 6 centimeter, let it be V1. V1 is equal to volume of the sphere with the radius 6 centimeter, that is our V1. V1 is equal to 4 by 3 pi r cube is equal to 4 by 3 pi into 6 cube. 4 by 3 pi into 6 cube. Now V2, that is the volume of the sphere with the radius 8 centimeter, that is 4 by 3 pi r cube is equal to 4 by 3 pi into 8 cube. 4 by 3 pi into 8 cube. Now V3 is equal to, that is the volume of the sphere with radius 10 centimeter, 4 by 3 pi r cube is equal to 4 by 3 pi into 10 cube. 4 by 3 pi into 10 cube. Okay, now I am going to add these volumes. Sum of the volumes of the 3 spheres, that is V1 plus V2 plus V3 is equal to 4 by 3 pi into 6 cube plus 4 by 3 pi into 8 cube plus 4 by 3 pi into 10 cube. We can see that this 4 by 3 pi is common, just take it outside. Then 4 by 3 pi into 6 cube plus 8 cube plus 10 cube. 6 cube plus 8 cube plus 10 cube, that is 4 pi by 3 into 6 cube is 216 plus 512 plus 1000. This is equal to sum of these volumes V1 plus V2 plus V3, that we will get it as 4 pi by 3 into 1728 centimeter cube. Okay, 1728 centimeter cube. Put it as equation number 1. Now we need to find out the radius of the radius of the sphere after conversion. Okay, so let that radius, let it be capital R. Okay, let capital R be the radius of the resulting sphere. Okay, let capital R be the radius of the resulting sphere. Then volume of the sphere with radius capital R is equal to 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. This is equation number 2. Volume before conversion, that is equation number 1, and volume after conversion, that is equation number 2. Volume before conversion, that is equation number 1, and volume after conversion, that is our equation number 2. Okay, equation number 2 and equation number 1, they are equal. Okay, equation number, according to the question, equation number 1 equal to equation number 2. That is 4 pi by 3. 1728 is equal to 4 pi by 3 r cube. Okay, 4 pi by 3 is common. On both sides we have 4 pi by 3. Just cancel it. Then we will have get r cube is equal to 1728. We will get r cube is equal to 1728. And thus 1728 we can write it as 12 cube. Okay, 1728 we can write it as 12 cube. So r cube is equal to 12 cube. That implies r is equal to 12. That implies r is equal to 12. Hence the radius of the resulting sphere is 12 centimeter. Hence the radius of the resulting sphere, that is 12 centimeter. Third question. A 20-meter deep well with a diameter 7 meter. Okay, well, the shape of the well, that is a cylinder. Okay, well means a cylinder. Depth is given, that is 20 meter. Diameter is given, that is 7 meter. Okay, diameter is given, that is 7 meter. A 20-meter deep well with a diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform. Okay, evenly spread out to form a platform 20 meter by 14 meter. 20 meter by 14 meter. That means L is equal to 20 meter and breadth is equal to 14 meter. Okay, that platform, that will be in the shape of a cuboid. Okay, we need to find out the height of the platform. Okay, we need to find out the height of the platform. Okay, this platform means a cuboid. Okay, length, the breadth is given and we need to find out the height of this platform. Okay, so first we have one cylinder and after conversion we have one cuboid. So first we are going to find out the volume of cylinder. Since diameter is 7 meter, cylinder radius is equal to 7 by 2 meter. Cylinder radius is equal to 7 by 2 meter. And height of the cylinder, that is equal to 20 meter. It is given in the question. Now volume of the cylinder is equal to pi r square h, and that is equal to pi into 7 by 2 all square into 20. Pi into 7 by 2 all square into 20. And this we will get it as 22 into 7 into 5. Okay, 22 into 7 into 5 meter cube. This is the volume of the cylinder, or that is the volume of the earth dug out. Okay, this is the total amount of the earth. Now, platform, that is a cuboid, then volume of the platform is equal to volume of the cuboid, that is equal to LPH, that is equal to 22 into 14 into H. 22 into 14 into H. Now put it as equation number 2 and this is our equation number 1. According to our question, equation number 1 and equation number 2, they are equal. So we can equate equation number 1 and equation number 2. That is 22 into 14 into H is equal to 22 into 7 into 5. 22 into 14 into H is equal to 22 into 7 into 5. That is H is equal to 22 into 7 into 5 divided by 22 into 14. That is H, we will get it as 5 by 2 and it is equal to 2.5. H is equal to 2.5 meter. Hence the height of the platform is 2.5 meter. Now fourth question. A well of diameter 3 m is dug 14 m deep. Well means a cylinder. Diameter it is given, that is 3 meter. Diameter is equal to 3 meter. Then radius is equal to 3 by 2 meter. Depth of the well is given. Depth means height of the cylinder. Height of the cylinder, that is equal to 14 meter. Therefore, volume of earth taken out by digging the well, that is equal to volume of the cylinder. Well, that is in the form of a cylinder. So, volume of the earth taken out by digging the well. Okay, volume of the earth taken out by digging the well, that is equal to earth taken out is equal to volume of the cylinder is equal to pi r square h. This is equal to pi into 3 by 2 all square into 14. And this we will get it as 63 pi by 2 meter square. Put it as equation number 1. And in our question, it is given that the earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter. Okay, earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter. Circular ring of width 4 meter to form an embankment. Find the height of the embankment. Okay, so suppose this is our well and we are going to spread that earth. Okay, so this is our embankment. Okay, this shaded portion, that is actually the earth and that is our embankment. And it is given that the width, that is 4 meter. The width of that portion is 4 meter. Now we have one circular ring. Circular ring means we have the portion which lies in between two circles. Okay, circles, concentric circles actually. And the radius of that well, or the radius of this portion, well, that is a cylinder, and that radius it is given, this is 3 by 2 meter. Okay, 3 by 2 meter. Now we want to find out the volume of this shaded portion. We want to find out the volume of that shaded portion. This first portion, that unshaded portion, that is our well and that is a cylinder. And we are going to spread the earth taken out from this well evenly around this well. So this portion, that is also, that shaded portion, that is also a cylinder. Okay, shaded portion, that is also a cylinder. So if we want to get the area of the shaded portion, first we need to get the area of this biggest cylinder. Then we need to minus the area of our smallest cylinder. Okay, volume of the biggest cylinder minus the volume of the smallest cylinder. Volume of the biggest cylinder minus the volume of the smallest cylinder. Okay, smallest cylinder, we don't want to consider that full well. Okay, we don't want to consider that full well. We need to consider only the portion of that well. Okay. So the height of this portion, that the height of that smallest portion, okay, that height of the well above of earth. Okay, height of the well above of earth, that we need to consider. Okay, height of the well above earth. We don't want to consider the height of the well inside the earth. Okay, we need to consider the height of the well only from above earth. Okay, so that height and the portion, that embankment height, that should be equal. So that height I am going to take it as h. Height, that let it be h. And for the first one, The small portion radius is 3 by 2 m, and the external radius is equal to 3 by 2 plus 4, that is equal to 11 by 2. Yeah, 3 by 2 4, 3 by 2 plus 4, that is equal to 11 by 2. Yeah. Now volume of the embankment, volume of the embankment is equal to biggest one. Okay, let the radius of the biggest one, let it be capital R, pi r square h minus, okay, the small one, pi r square, small letter r square, and the height of that is, that two portions are equal, so pi r square h minus pi r square h, and this is equal to pi h, we can take it outside, and capital R square minus small r square, and that is equal to pi h into capital R square, that is 11 by 2, and the small radius, that is 3 by 2. So 11 by 2 all square minus 3 by 2 all square. Pi h into 11 by 2 all square minus 3 by 2 all square. So this is equal to, that we will get it as volume of embankment, we will get it as 28 pi h meter cube. 28 pi h meter cube. Put it as equation number 1. What is the speciality of equation number 1 and equation number 2? Equation number 1, that is the total amount of the earth, total amount of the earth taken out by digging the well. And equation number 2, that is the volume of embankment. Okay, in embankment what we have actually the earth taken out by digging the well, right? So the equation number 1 and equation number 2 are equal. Equation number 1 and equation number 2 are equal according to our question. According to our question, equation number 1 is equal to equation number 2, that is 63 by 2 pi is equal to 28 pi h. 28 pi h. Pi get cancelled because on both sides we have pi, and 28 h is equal to 63 by 2. We will have 28 h is equal to 63 by 2 we will get, and from this h is equal to 63 by 2 into 28. 63 by 2 into 28. This is equal to 9 by 8 is equal to 1.125. So the height of the embankment is 1.125. You should keep it in your mind. The area of the volume of that embankment, that is actually a circular ring. If we want to find out the volume of the embankment, we need to find out the volume of that outer portion minus volume of the inner portion. Inner portion, that is actually the part of the well, but we don't want to consider that full well. We need to consider the portion of the well which lies above our ground, and till the height of the second portion. Okay, till the height of the second outer portion. So that height we took it as h. Okay, don't take the height of that inner portion as the height of your well. Okay, we are not considering the total well, we are only considering the well portion which lies above our ground and till the outer portion, till that where we spread out our earth taken out by digging the well. Okay, now the fifth question. A container shaped like a right circular cylinder having diameter 12 centimeter. Fifth question. Container. The shape is cylinder. And it is given that the diameter is equal to 12 centimeter. This implies a radius is equal to 6 centimeter. Height is given. Height of the cylinder, that is equal to, what is the height of the cylinder? 15 centimeter. He is full of ice cream. The ice cream is to be filled into cones. Okay, so the next figure is cone. Cones of height 12 centimeter and diameter 6 centimeter. Thus implies radius 3 centimeter. Having a hemispherical shape on the top. So we have hemisphere also. Hemisphere. That hemisphere we have on the top of this cone. Then the radius of cone, that should be is equal to radius of hemisphere, that is equal to 3 centimeter. Find the number of such cones which can be filled with ice cream. Find the number of such cones which can be filled with ice cream. We need to find out the number of such cones. So we are going to use this information to find out the volume. Okay, first we are going to find out the volume of cylinder. Okay, volume of the cylinder, that we know. What is the volume of cylinder? Pi r square h. This is equal to pi into 6 square into 15. And this is equal to 540 pi. 540 pi centimeter cube. That is the volume of cylinder. Okay, volume of cylinder. Now we are going to find out the volume of cone. V is equal to volume of the cone is 1 by 3 pi r square h. That is equal to 1 by 3 pi into r is 3 square into 12. 1 by 3 pi into 3 square into 12. That is equal to 36 pi. That is equal to 36 pi centimeter cube. Okay, now we will find out the volume of hemisphere. Volume of hemisphere, that is equal to 2 by 3 pi r cube. Okay, volume of hemisphere, that is equal to 2 by 3 pi r cube, and this is equal to 2 by 3 pi into 3 cube. Pi into 3 cube. This we will get it as 18 pi centimeter cube. 18 pi centimeter cube. So we got the volume of cylinder, cone and hemisphere. Okay. The volume of ice cream to be filled in a cone with a hemispherical shape on the top. Volume of ice cream. Okay, to be filled in the cone, ice cream to be filled in the cone with the hemispherical end. With the hemispherical end is equal to volume of the cone plus volume of the hemisphere. Volume of the cone plus volume of the hemisphere. That is, what is the volume of cone? 36 pi plus volume of the hemisphere 18 pi. It is equal to 54 pi centimeter cube. Okay, let n cones be filled with the ice cream. Let n cones be filled with the ice cream. Okay. Then volume of ice cream to be filled in n cones. Okay, this is the volume of ice cream filled in one cone. Then volume of ice cream filled with the n cones. Volume of ice cream filled with the n cones is equal to n into volume of ice cream filled with the one cone. Okay, that is equal to n into 54 pi. This is equal to 54 n pi centimeter cube. 54 n pi centimeter cube. Now, according to the question, okay, this much of ice creams we can fill in n cones, and total we have 540 pi ice cream. Okay, total we have 540 pi ice cream. So, according to our question, these two values should be equal. Okay, suppose it is equation number 1 and it is equation number 2. According to our question, equation number 1 is equal to equation number 2. That is 54 n pi is equal to 540 pi. 540 pi. Then n is equal to 540 divided by 54. That is equal to 10. Hence, 10 cones can be filled with the ice cream. Hence, 10 cones can be filled with the ice cream.